away. Just take a look at these answers. These two balloons were to repel each other. Why we can't use that observation to prove that these are both negative for number 3? Well, it's because they would still do the same thing if they're both positive. So they can be positive. Don't you just love the smell and taste of balloons? What if you got these two balloons to zook, attract, or another class did? And so therefore they're saying that, oh, well, then that must mean that these balloons are made differently. They're made of different materials. This is made of material that would become negative. This is made of material that would become positive. And that's why you have your attraction. No! How else can you get attraction between objects? Okay? Besides positive, negative, negative, positive, positive, negative, is charged and neutral. So like positive, neutral, negative, neutral, you can still get attraction. Maybe that happened because this other class wasn't following their procedure and didn't care about the integrity of the experiment and didn't really charge this well. And so they charge this one, but not in that one. So they have a charged, neutral, charged and neutral will attract. Try again. Hanky and ruler. Hanky and ruler. We found that plastic objects tend to gain electrons, become negative. Clothing, fabric tends to lose electrons, become positive. So negative, positive, they should attract, right? But some other class got them to repel. Like, how does that work? Well, what if the metal rod, which of course I don't have, were like behind the hanging plastic roller, and the hanging plastic roller, which is charged, was really attracted to and stuck to that metal rod. And so as you brought in the hanky, they saw the ruler move away from it and stick to the metal rod. Well, it's not because there was repulsion there. It's because actually there was a stronger force of attraction between the charged ruler and the metal rod. Process by which neutral can be attracted to a charged object. It's like with this thing, we charge the balloon negatively, brought it in toward a neutral wall. The negative charge of the negative balloon repels the negative charges in the neutral wall. That leaves a positive zone here to be attracted to the negative balloon. Okay, so that process and this separation of charges in a neutral object where you have more negative over here, more positive over there, it's called polarization. Balloon on your head. Bring your head near a neutral wall. So rubbing the balloon on the head, whatever hair you have. So hair, fur, stuff like that tends to give electrons away, become positive. This becomes negative, but it's gone. So I got my positive head here, bringing it toward a neutral wall. The positive charge of my head, of the fur on the top of my head, positive charge will attract the negative charges in the neutral wall, okay, and polarize it. So the negative charges move toward my hair, the little bits. And what do the positive charges do in each? My head in the wall, they don't go anywhere because they're stuck with the neutrons in the nucleus. And the same goes for number 8 with the positive charges in B and C. However, if you bring a negatively charged acrylic painting toward a neutral wall, it would be just like this. So pretend this balloon is a negatively charged acrylic painting, because acrylic is rubber. You bring it near a neutral wall. What happens to the negative charges? They move away. What happens to the positives? They don't go anywhere. They stay still. Okay? So the negative charges move away. The positive charges don't move. Lastly, what brought us here in the first place? This whole unit. Well, no, not the whole unit. To this investigation. The girl on the slide, the GIF. The girl's clothing. We asked, the girl slid down the slide. I don't have it pulled up. She slid down the slide. She gets charged, her clothes get charged, and then the slide gets charged. Which one gains electrons, which one loses? Well, the slide is made of plastic. Plastic tends to gain electrons and become negative. Clothing, as we learned, tends to lose electrons and become positive. That's it. That's a wrap. Bye-bye.